This one is question 1B, right? Is it correct? This is the question that we want to discuss.
Yes.
Okay, so for this question, the diagram shows pair of charge Q1 and Q2, where Q2 is greater than Q1. Okay, it says that Q2 here is greater than Q1 in terms of the magnitude. And then place on AB line. So this is the line. Lines with arrow represent the electric field produced by the pair of charge. State the sign of each charge. So from the direction of the electric field here, kalau going out, maksudnya dia apa? Positif ke negatif?
Positif.
Positif. Kalau dia going in, dia adalah negatif. So straight away you know lah that Q1 is negative and Q2 is positive. Okay, the next question, they want to determine the position of the point on the AB line where the resultant electric field intensity produced by the charge is 0. Okay, over here, so it says here that the position of the point along AB line. So AB line is actually from here to here, right? So at this any point over here, it doesn't matter where is the point, you will have electric field, two electric field. One come from the E1, which is to the left. Then because this one is going in, right? Now another one E2 is going to the left as well. So because you don't have the cancellation of electric field, it cannot be 0. Okay? So the answer would be the position. So none. Like a tricky question, eh? None because E1 and E2 in the same direction, so they can't cancel each other. Okay.
So yang soalan ni dia tak ada bagi formula ke apa
In this regards, you don't have to state anything now because straight away you know the direction is most of those are in the same direction, so it can't be 0 lah. Dia tak boleh cancel out pun.
Okay, faham.
Okay. So that one's for question 1B. The next question is question 1C. Question 1C is this one, I think, yes. Okay, in this question it says that the 2 points A and B 3 and 4 meters away from the charge Q, respectively, as shown in figure 3. If charge Q is 4 microcoulomb, the Q kat sini 4 times 10 negative 6 coulomb. Determine the potential difference between point B and point A. So logically, if you want to find potential difference, so basically you want to find delta V. Okay, if it is VBA, then you will have VB minus VA lah. So in this case, they just want to find the difference. It doesn't really matter which one minus which one. So let's say if you get negative, it should be okay as well. And the answer is correct as well lah. If you do VA minus VB, the answer is correct. But if the follow-up question, let's say they want you to bring the charge from A to B or B to A, that one you have to be particular when you calculate delta V. Okay, because if you want to calculate work, you have to use Q naught delta V kan. So in this one is very important you use final minus initial position. Kalau setakat difference like this, it's okay. Okay. So here let's say I use that one. So my suggestion is to calculate separately VB and VA. You can calculate straight away, tak ada masalah pun. So equation for V is equals to KQ over R. So K is 9 times 10 to the power 9. Q is the source there, 4 times 10 negative 6. And then R kalau untuk B, is 3. So it got 0 duluan. Okay. Untuk A will be 9 times 10 to the power of 9, 4 times 10 to the power of 6. The only difference here would be the distance, which is 4. Okay. So if I want to calculate delta VBA, it's 9 times 10 to the power of 9, multiply 4 times 10 to the power of 6, okay, 1 over 3 minus 1 over 4. So the delta VBA, did you get 3000 for this one?
Yes, sir.
Sama ya. So you get the answer kan? Okay, so tak ada masalah kot. Okay, any question that you want to ask regarding this question?
No, sir.
Ya.
Ada sir. Faham tak?
Ada. Okay. So that one's for 1, B and C. Okay, the next one, maybe you can discuss question number 3. This is the question number 3. Sorry. Oh, that one. Okay, 3C, 4A2, and then lastly is 10A, 10A, 10A. This will be 4A, sorry, 3C, everybody 3C. Okay, they give you circuit consists of 4 resistor. That one is resistor. Kotak tu ada resistor. Dalam exam dia akan buat yang the actual symbol lah. This one maybe practice je kot. So dia buat macam tu. Okay, dia kata figure 5 shows a 2 ampere current flows into combination of 4 resistor. Calculate the equivalent resistance of the combination. Current that flows is 3 ohm resistor and the power dissipated by 12 ohm resistor. So they want to calculate equivalent resistance. Current that flows 3 ohm dengan power dissipated by 12 ohm. Okay, first thing first, I would like to label yang this one lah, so that nanti kita nak kira senang sikit. So this one R1, I put this one as R2, I put this one as R3, and this one as R4. Okay, that one is I lah. Okay, before we solve for the R factor, maybe if you cannot see, you have to rearrange lah. If you rearrange, you get something that looks like this. So basically what I did is that I just straighten this part dan saya tegakkan je. So that I have resistor 1 over there, resistor 2 over there, resistor 3 over there, and resistor 4 over there. Okay. So even though the initial diagram looks a little bit complicated, but once you rearrange, this one becomes clear lah. These two are in series ke parallel? These two.
Series.
Series kan? So R34 is in series as well. So once you calculate this one and this one, you can solve using parallel. So that's the idea. Okay, I just do it in one step lah, to simple je kan. So R equivalent. Kau pakai effective ke equivalent? Betul.
Effective.
EFF.
Okay, so we use EFF lah untuk formula sheet kamu. So REFF, kalau saya nak calculate untuk 1 dengan 2 dulu, okay, kita calculate 1 and 2 dulu. So the combination of R12 is equals to R1 plus R2 because these ones are in series. So it will be 3 plus 6, which is 9 ohm. R34 is equals to R3 plus R4, which is equals to 9 plus 12. This one is 21. 21. Betul. Okay. So if you want to calculate R effective, 1 over R effective is equals to 1, 2 plus R34 because we are in parallel to each other. Okay, and then don't forget that this one is 1 over. So if you calculate R effective, you have to take the inverse. Itu yang selalu student lupa lah, kadang-kadang saya lupa juga. So the best way is that if you get some weird numbers, then kamu most likely salah kira lah. Dia basically region over there juga lah. 1/9 plus 1/21. 1 divided by that one is 6.2. So my R effective is equals to 6.2 ohms. So I think this one should be okay. Tak ada masalah. Okay, the next question they want to calculate the current that flows in the 3 ohm resistor. Okay, 3 ohm resistor is over here. On the 3 ohm. So basically they want to calculate I1. Okay, how do you calculate I1? Kamu nak kira I1? The easiest way, okay, kalau saya kira this one is the current from the circuit, I mean this one is like total current, and then if I assume that this is R effective, okay, so basically I can calculate V total ataupun V terminal, okay. And then if I calculate V terminal yang this part, sebab apa ni, this one are in series, it will be the same lah. VT over there is equals to VT over here. So, jarak dia tu sama panjang kan. This one akan sama. Faham ke tidak ni?
Faham.
Alright, in another way I can write down that V terminal is equals to V12 sama dengan V34. Okay, so we have to calculate V terminal first. Kalau yang V terminal ataupun V total tu sebenarnya kita pakai V equals to I R. Okay, dan syarat I tu mesti I of the circuit total lah. And then I ni R effective. So we calculate V terminal using I tadi, I diberi 2 multiply by 6.3. So you should get 12.6 volt. Okay. So if I already have that one, kalau saya combinekan yang ni kan, tadi tu, let's see if I do combination of those. So in a way, saya rasa we might have if you draw bila dia dah combine itu as well. But if you want to calculate the next part, most likely you have to still use that one. So just now it looks something like this lah. So this is basically V12 and this is the part for V34. Okay. So as long as I use R12 there, then I can get the I12. Okay, and since I12 is basically the current that passes through this one and that one, so basically it's actually I1 as well. Complete that.
Faham.
Okay, so the next part I still use the ohms law, V equals to IR. So basically I use R ni 12, I will get I for 12 and I have to use V for 12. Okay. Before this, we know that V terminal is equals to V12, so I can write down this one as V terminal V12. Kan? Saya masukkan sini 12.6 equals to I12. R12 is 9 ohm. So I12 is equals to 12.6 divided by 9, should get 1.4 ampere. Okay. And this one is basically I that go through I1. R1 lah. Nak R1 tadi kan. So final answer sebab kamu sendiri yang label R1 tu semua apa kan. So we can write current that passes through R equals to 3 ohm is 1.4 ampere. Okay, any questions?
Tak ada sir.
No, sir.
Okay, that one is for C2. We still have to do C3. Okay, C3 pula maksudnya kata find the power dissipated by the 12 ohm resistor. Okay, so if you want to use to calculate P over here, so basically you have to use P equals to I squared R. Okay, I have to use R correspond to the 12 ohm. I have to use I correspond to the 12 ohm as well, the one that passes through that particular resistor lah. So I already have the current that passes through that part. So tadi kita dah kira, maksudnya bila yang dia keluar kat sini adalah 2 ampere, okay, ataupun yang masuk ni adalah 2 ampere lah. So bila dia into the junction, just now we already calculate, yang pergi ke kiri ni is 1.4. Okay. That means yang go through over here is 1.6. Sorry, 0.6. Okay, so 0.6 tu lah yang akan passes to R4 yang kita nak cari tu, yang 12 ohm. So kita pakai I dia adalah 0.6. Faham ke tidak?
Faham, Syah?
Okay, so yang tiga tu, if you want to write calculation, I can write I berapa tadi? I4 sama dengan I yang masuk tu minus dengan I pergi sana, which is 1, 2. Ni I3, 4 lah sebenarnya kan. So B2 minus 0.1.4. So you get 0.6 ampere. Okay, this is actually equals to I equals 3 equals to I4. Tapi kita nak pakai I4 tu saja. So therefore, power dissipated P is equals to I squared R. So I want to use R4, so I have to use I4. R4 dia adalah 12 ohm. Okay, to be 0.36 times 0.6 square times 5. We have 4.32. What is the unit for power?
What?
Yes, very good. What? Okay, that's good. Here is for question 2. Okay, the next question is question 4A2. Okay, 4A ni kita baca balik lah, saya tak baca soalan ni. Kata question is based on the experiment conducted by NASA on a novel source of energy for a space shuttle. Above the equator of the Earth's magnetic field run horizontally in the south-north direction. Horizontally in the south-north direction. Okay, so maksudnya kamu bayangkan kamu tengah terbang ni, kalau kamu terbang kan, tapi dia shuttle lah. And then kamu punya magnetic field tu, dia cross horizontally. Maksudnya melintang lah yang kamu south-north direction. A space shuttle from west to east above the equators. Apa tadi? Space shuttle flying from west to east above the equator cuts perpendicularly across the magnetic field as shown diagram below. Small satellite is attached to the shuttle, but very long thin copper cable is proposed to use the EMF generated in the cable as a source of electrical energy of the shuttle. So you know that if you have a straight conductor cutting through the magnetic field, it will produce an induced EMF. Okay. So answer A, you can answer change in magnetic flux based on definition for induced EMF. Why is that EMF generated in the cable? Because due to change in the magnetic flux. Okay. So maksudnya ni kan, dia kata benda ni bergerak daripada space shuttle flying from west to east. So maksudnya dia bergerak macam ni kan. Ini adalah west, ini adalah east. Okay. Lepas tu dia kata yang magnetic field tu from west to east. Sorry, mana tadi? Sorry, in the south north direction. Okay, south ke north. So ini kamu punya field. Ni kalau kamu nak itu macam 3D juga. So basically this is the aeroplane tadi tu. Kalau kamu tak nampak lah sebenarnya cuma siapa. Okay. And then kamu pilih ke atas macam ni. Okay. The magnetic field along this direction macam tu. So dekat through lah. Okay, question 2, part 4A2, dia kata calculate the magnitude of the EMF using the following data. Dia kata cable length L is equals to 20 km, change straight away to meter. Speed of the shuttle V is equals to 7 km per second. And change to meter as well, jadi kilometer to meter 7,000 lah, meter per second. And horizontal component of magnetic field is 6 times B is equal to 6 times 10 negative 5. That's all. Okay. So to solve this one, you have to use the only one equation yang kamu ada long straight conductor cutting through the magnetic field. So you have to use EMF equals to BLV sin theta. Okay. Where V itu adalah angle between B dengan V. So B dia ke sana dan V kamu ke sini. So angle dia berapa?
90.
Yes, sin 90 degrees. So B dia adalah 6. L dia adalah 20 times 10 to the power of 3. And this one will be 7,000 BLV kan. Sin 90 degrees. Sin 90 degrees is equals to 1. So you don't have to press that one. You should get 8.4 times 10 to the power of 3. Okay, ni saya tengok jawapan tadi lah. Betul ke tidak jawapan itu?
Betul-betul dapat.
Betul okay. Now, the last part, yang part 3 tu dia kata, state the direction of generated EMF. Okay, so that one, generated EMF, kalau ikut ipisan saya ni kan, B dia ke kanan. So, kalau kamu nak buat right hand palm tu, kau pakai tangan kanan. Lepas tu, jari kamu semua ke sana. It's like that. Okay. And then, kamu punya okay. V kamu tu ke depan, so thumb kamu tu ke sana. Okay, so kamu punya force tu slide yang ke depan kan. Sebab ini adalah current, so dia sama direction dengan positif. So this one adalah current direction ke atas. Okay, kalau elektron di bawah kan, so current dia atas. Okay, so sepatutnya daripada shuttle ke satellite. Okay. Biasanya dia tanya direction of current tau. Kalau current tu memang senang lah. Okay. So direction dia adalah upwards ke ataupun from space shuttle to satellite. Okay.
Okay, sir, faham.
And then the last question here yang kamu minta macam adalah question number 10A. Okay, soalan 10A ni disuruh calculate the mass defect and binding energy per nucleon. For the nucleus of this one, okay, given the mass is this one and mass of proton is that one. Mass of neutron is this one. Okay, dia beri straight away dalam, so you don't have to pusing-pusing ke atas lah, pakai je. Okay, so the mass defect. Mass defect, the symbol that we use is delta M, which is Z and P tambah NMN. Ini adalah individual punya mass. Okay, total proton dengan total neutron minus mass of nucleus. Okay. Because they give you mass of nucleus, mass of CO2 in terms of U, so everything need to use U juga. So from this one, 6329 Cu, we know that numbers of proton Z is equals to berapa? Number of proton berapa? Berapa banyak proton based on this one? Dan put
29.
29. So it will be 29. Numbers of neutron will be neutron number to minus dengan 29. So this one should be
34.
84.
34.
84.
34.
Okay,
Okay.
34. Okay. So I can substitute back inside this equation dan dengan 29 times with MP 1.007276 plus 34 times mass of neutron 1.008665 minus mass of nucleus. Kita buat satu kat bawah ni. 62.5219. So you have to solve this one first and then tolak yang that one. Itu kalkulator kamu tak ada masalah tu. Tak dapat yang ni.
Dapat 0.983714. Kena ambil semua tu bisa?
Yes, kita akan 52, 19, 0.983714. Betul.
Sama.
Okay. Biasanya kalau you ataupun yang ni lah chapter ni kita ambil je semua. Tak ada masalah. Final answer nanti baru kamu gunakan. So yang ni macam so dia ada follow up question. So kita kerja je lah. 0.983714. Unit dia apa?
U.
Okay. The next question that I want to find binding energy per nucleon. Okay. Kalau binding energy BE, we can use delta M tu darab dengan 91.5 straight away sebab dia dalam U kan. So delta MC square itulah dia. So it will be 0.983714 multiply with 931.5. Okay. So you should get binding energy equals to 916.3296. Okay, this one is energy, so the unit will be apa ni? Unit apa?
NEV.
NEV jangan tulis joule pula sebab kamu kira tadi dalam NEV. Yang U tu bila kamu kira kamu dapat NEV, tapi yang ni tak ada lagi. You want to find BE per nucleon, binding energy per nucleon. You just have to divide this number.
Sir.
Yes.
Yang 91.5 tu dia.
Mana? Yang mana?
91.5.
Itu datang daripada constant. Dalam list of constant dia.
Oh.
Kita tengok dapat cukup. Okay, saya naik atas, macam tu ada. Okay, so kalau kamu tengok list of ni, itu dia ada kata atomic mass unit tu 1U sama dengan 91.5. So kalau kamu nak cari dalam NEV, kamu cari dalam 91.5 tu darab dia. Okay. So this one you have to divide by berapa number of ni nucleon ni?
63.
63, yes. Yes, excuse me. I got his 14.54. Okay, again the unit will be NEV, but now per nucleon.
Sir,
NEV,
kalau okey, kalau saya tukarkan semua ni jadi macam unit
Joule.
tadi kan delta M kan jadi kg,
boleh.
lepas tu energy pun jadi joule.
Boleh? And then jawapan dia memang akan lari banyak juga sebab itu mass tu kalau dalam SI unit dia tak banyak decimal place, jadi kita pakai constant kan. You still get the same, maybe tak same lah, but then similar answer, tapi cara dia dua betul no.
Okay, sebab saya buat macam tu, semua macam tak sama, so buat saya tanya.
Okay, and then even for this one sebab dia tak kata final answer tu, dia tak cakap whether you want to find in mega electron volt ke dalam joule ke, dia tak cakap, so you can leave it in joule. So dulu betul lah, kalau kamu biar dalam joule, dia jadi joule per nucleon, dia jadi mini pula. Okay, any other question?